All right, let's get started. Welcome. Thank you everyone for coming. My name is Philip Taylor. I am a volunteer with SEAC's Education Committee. I'm glad to have you guys here with us today. Looking forward to hearing this presentation about Alloy Sunnyside. This is a exciting project for the entire neighborhood. I'm a former resident of Sunnyside and a former board member of the neighborhood organization. So this neighborhood is kind of near and dear to me, and I'm looking forward to seeing how this changes our neighborhood. Just a couple of quick announcements before we get started. Everyone should have received a blue drink ticket at registration. We welcome everyone to come back to Diebold after the Hard Hat Tour. I can vouch for this brewery. I've been here more times than I like to admit. And I highly recommend the Vladislav if there's any stout fans among us. Couple of announcements from the committee. We're looking forward to hosting our 2022 fall seminar. It's going to be October 13th in Westminster. And a couple of really exciting topics this year. One is sustainability and structural engineering. We have a great speaker from the San Francisco area, Megan Stringer, who's going to be talking about what structural engineers can do to better account for how our structures, the embodied carbon in the structures that we design, and how we can have a lighter footprint for the global climate. And the other presentation is by Emily Guglielmo, a well-known structural engineer from Martin Martin, who's going to be talking about frequently asked questions with wind design and updates to ASCE 722. Are we able to advance the slide? Oh, I'm being transcribed. That's great. Oh, thank you. Thank you. Quick shout out to our fall seminar sponsors. Without their generous support, we could not put on these programs for SEAC members and non-members alike. Gold sponsor, Lamwood Systems, silver sponsors, Woodward, GEI Consultants, PCI Mountain States, SECA, Hilti, and Nucor, and our bronze sponsor, Park Range Construction. Thank you so much. Yeah, quick plug for the Education Committee. We're always looking for new members. As I mentioned earlier, the fall seminar is sort of our flagship event of the year. We also put on project presentations and hard hat tours, such as what we're doing today. And we support PE and SE study groups and sort of getting people together to kick off and combine resources to get licensed. So if anyone's interested in joining the Education Committee, feel free to contact us at education@seaccolorado.org. Also, we're always looking for new projects to spotlight. So if you are designing or involved in a project that you can teach people what you've learned from that project, our SEAC members benefit greatly from that experience. So feel free to propose any new projects for next year's cycle of project presentations. All right. Okay, let's get ready for the presentation. I'm going to give a quick introduction to our speakers. First, we have, I'm sorry, Eric Donor from Ratio Architects. Eric is a senior associate with Ratio Architects. He specializes in both market rate and affordable multifamily housing, where he directs all phases of projects from early stage community engagement to design and construction administration. As an integrator committed to fostering positive relationships, Eric brings balance to his work, cross-pollinating diverse ideas. Ultimately, he seeks to enhance lives through design. And one fun fact about Eric is he is actually a major in electrical engineering before he turned over to the dark side of architecture. Our next speaker is our structural engineer, Lauren Grenz from IMEG Corp. Lauren is a senior structural engineer with IMEG, a full-service engineering and consulting firm of 1,600 employees nationwide with 60 office locations. She has over 15 years of experience designing projects ranging from high-rise residential buildings to historic renovations and custom homes. Recently, Lauren completed Laurel, a luxury condominium building with garage and retail space in the Cherry Creek North area of Denver. Lauren comes highly regarded by clients for her project management skills and design abilities. And a fun fact about Lauren is that she has a master's in divinity in addition to structural engineering. And our final speaker, we have a substitute replacement for Nathan Russell. We're going to be hearing from Rodrigo. Rodrigo, your last name? Pereira. Rodrigo has 5 years of experience with Catamount. He focuses on multifamily, and he's a project engineer. And a fun fact about Rodrigo is he was born in Brazil. So without further ado, Eric, I'll hand it over to you. We're going to have questions for folks in the audience as well as folks from the webinar after the presentations.
All right, so I'm going to give a little overview of the project and how it came about. This is a look at the station area plan for the Fox Street commuter rail, and this is a part of Sunnyside is developing a lot. You've seen a lot of like the ZIA go up and a number of those buildings, and so my client, Prime West, was looking for to get into that market area. And is there a laser on this thing? Yeah. And so here you can see where the project site is in relationship to the kind of planned densities in that area. And as you're kind of getting closer to the tracks, the buildings keep getting taller and taller and more dense. This project, because this area hasn't been zoned that, each project has to be rezoned. And to be rezoned, they have to get the support of the community. So I don't know if, Philip, if you were part of the community organization at that time or not, but we met with the community, kind of heard what their concerns were about the location. We go to this slide. One of the primary things the community was really interested in was the connection to the commuter rail stop and providing kind of a safe streetscape to and paths to that location. They were also concerned about transportation, the amount of cars that these sorts of buildings would be bringing to the site. And I'll touch on that in a moment. And then also just that it would fit within the character of the neighborhood. The neighborhood, right, well, as you can kind of see, a lot of it is single family homes. And so it's kind of hard to match that, but there's a lot of kind of industrial zones further north and along the tracks. And so looking at ways we could pick up some of those characteristics. When we zoomed in and looked at that original site, you can see there was really no sidewalk of any kind in the east-west direction on 42nd. This was a map we pulled from the city showing like where all the missing sidewalks were and just the problems of the neighborhood navigating to that stop. In the project, we're pointed out as like, oh, well, we can't affect the rest of the street, but we have this part of the block that we actually can influence. And so looking at how, well, before I get into that, the client came to us with this program saying, hey, we want to do a mixed use multifamily building somewhere around 209 units. We want it to include a retail space. Part of the community organization there, they really wanted to create this sort of kind of main street and not just have all residential buildings. They wanted small shops, mom and pop restaurants, things like that. And so Prime West was looking at, well, how can we incorporate that into our building to be responsive to the neighborhood? Another aspect of that responsibility, if you will, is the 10% affordability. A lot of these multifamily housing projects, I think the laws have changed a little bit now. You used to either pay into affordable housing fee or actually build the affordable housing. Our client went above and beyond. They technically could have only built maybe 2% affordable housing, but they wanted to get that support of the neighborhood. And so they incorporated 10% affordable housing in the project to be able to get the density and the height that they were petitioning the neighborhood for. And then just some of the other aspects of the building, there's leasing, lobby, amenity spaces. They wanted to incorporate a co-working space that might be able to serve double duty with the community. And then also just that street activation, the streetscape that I talked about earlier. Part of the kind of good stewardship was Enterprise Green Communities and then ultimately LEED Gold, which came into the project after it had already been submitted for permit. So that was interesting. And so when we were looking at the massing of the site, how do we start to influence that streetscape? We started looking at the characteristics that were on here, and the Zia, like really holding that edge of the street corner there, there was some kind of negative feedback from the community. And so we looked at, well, there's the cidery next door that's not going to be redeveloped for probably another 10 years. And so we thought, well, what if we pulled back from this corner, kind of push the mass of the building more towards the middle of the site and provide some better breathing room, if you will, there to create this potential for a different neighborhood characteristic in this area as it started to redevelop. Part of that was to allow daylight to get to that streetscape to create a little bit more pleasant, safe environment as people moved along the street to the light rail stop. And then also just looking at how does this massing start to affect the character of what's developed in this area. And then we went around the neighborhood, looked at what are the kind of defining characteristics of Sunnyside and how do we start to incorporate that into the building. And then just also materiality. The neighborhood was really interested in not doing a lot of stucco and fiber cement that you see on a lot of multifamily and incorporating more brick because of the characteristic of Horace Mann, the school just down the street, and some of the smaller residential buildings. And so here you can see that one of our earlier site plans, this conceptual site plan, which is fairly close to what is actually getting built. We looked at incorporating the retail on this corner. So there is a kind of synergy with the cider that was next door or cidery, and visibility to the light rail, pedestrian bridge and overpass. And then incorporating residential units on the ground floor that would have stoops and interface with that streetscape to put eyes on the street, make it more safe for pedestrians as they're navigating through the site. And then pushing the main building entrance more towards the middle of the block. And so this was the initial kind of conceptual design for the building. You'll notice the very flat site that was at this stage of the project, and that'll be a key aspect of the structure of the building and how that played out long term. But then the kind of ground level here, this was picking up cues from the elementary school Horace Mann down the street, and then trying to pick up some aspects of the industrial nature of the area and incorporate that brick. And so looking at that program, we started going through the zoning. They wanted it rezoned to CRX 8, which allows 110 feet height and up to 8 stories. When you get into the actual code, that doesn't quite translate. And so we went under the type 1B construction because that gave us the height that we could build that 8-story building that we were initially looking at. And then looking at the also the construction type, the allowable feet above grade plane. And so there was that aspect, but then as we started digging into it, there was also this concern about, well, we don't really want to go to high rise because that triggers a bunch of other aspects that were going to be difficult to accommodate on the site. And so remember this diagram because that'll come into play here in a second. So as we started designing, we realized actually, and got the survey info, there's about 10 feet of fall from Jason Street to the alley. When you look at fire code, the building becomes measured from the lowest point of fire department access. And so that was from the alley. And so we essentially lost a floor of the building. And what that ended up doing was it ended up pushing the building down and tightening the floor to floor. Let me back up here for a second. We looked at going to high rise, but you have to have access to 2 separate water mains. And then you have to incorporate pressurization, elevator lobbies, fire command control center. And because we're already squeezing the building so much, there just wasn't that space in the project to allow the pro forma to kind of eat up that square footage. Another aspect that was pushing on the building from the other direction was the below grade conditions. So as we were working through the design in concert with Catamount, they were pointing out, hey, there's a lot of bedrock there. It falls off on the south end of the site. It'd be great if you could flip your parking garage, get the deeper end on that side, and try to get out of the bedrock as much as possible. And then also you see there's groundwater here, and we had to incorporate a under drain system, which if you had to deal with that on any project like this, a lot of different things come into play with those under drain systems, where if you pump that outside or daylight it, then you have to treat it, all sorts of things according to the health department. And because water in this area will most likely have some arsenic in it and different things like that, it was almost a given that we'd have to treat it. In this case, however, because the ground bedrock fell off on that south end of the building, we're able to incorporate an under drain system that would capture any water coming from the north end that was a higher elevation and run it kind of around the building to this point to a dry well and release it back underground. And so then we wouldn't have to treat it. And then Lauren can touch on a little bit of how that affected some of the structural design for that bottom slab there. Another challenging aspect, because we had to flip that garage, we ended up getting a very complicated parking plate. And so you'll see this on the site tour. On the north end of the site, there's an entrance to a kind of the upper level parking that dead ends. On the south side of the site, there's another entrance that goes to a dead end second level, and then another leg that comes down and deeper to the lowest level of the parking deck there. We joked navigating the site that it ends up starting to feel a little bit like MC Escher's staircase down there. I did drop in this diagram here of that under drain system and how we're picking up any sort of flows of groundwater that come against that parking garage wall, capturing that, running it down to that under drain system, and then again to that dry well at the corner of the site. So we had these two pressures pushing on that building, and that really started to tighten that floor to floor. We ended up with a floor to floor of 9 foot 2 inches. And so then that started really locking in what sort of structural system we could use for these decks in the building. And so here's a cross section of that. It's a 5.5 inch infinity floor. It's a epid-pour deck. Lauren can get into maybe more of the specifics of that. And then we had to do a bunch of acoustical components to this to keep that cross section just as thin as possible. And so these units end up with 8.5 foot tall ceilings. A few other interesting aspects of this type of construction, if you're not aware, because we're in the 1B category, that means our structure has to be rated 2 hours. One thing that if you work with architects doing this type of construction, they're probably always hounding you on, okay, what is the primary structural frame? Because as an architect, I have to rate that individually from the wall. So if you have a column in a 2-hour wall, I still have to rate that column separately in a 2-hour configuration. Because we weren't high rise in a lot of these infinity type buildings, you can get a reduction to drop down to type 2 or 2A construction. So then all your ratings are 1 hour. It becomes a little bit easier. With the 2-hour, well, let me back up just a second. So here you can kind of see some of the configuration. And so we get all the load bearing, these light gauge and metal stud panelized system. These walls are what is the load bearing structure of the building. We do have some conditions where, like at balcony location, especially on the north end of the building, you'll see we had to incorporate a lot of steel columns just to get some of the building configuration that we were wanting to achieve there. But here you can see the 2-hour ratings for those load-bearing walls, and then the non-load-bearing walls within the units. There are some locations where there are load-bearing walls inside that unit, and so there gets to be some complicated UL assemblies, ratings, one aspect on the exterior walls, also because we're building to the property lines of the site. You end up with different conditions where, like on the south side of the building, because you're so close to the property line, you have to rate that exterior wall that's load bearing 2 hours from both directions. And that equated to 2 layers of sheathing on the exterior. Other locations just had 1 layer. And so it ends up being this coordination thing between the structural engineer, where that slab edge is, the shops, and the GC. There's a lot of things to be aware of as you go through that. And then again, that kind of condition where you have any primary structure, it has to be 2-hour rated. And so if this was occurring in a wall, then we have to either spray fireproof that if the column is small enough within that wall cavity, or if it's larger, then we could incorporate a gyp wrap around that. And then just real briefly, this is the current configuration of the building. You'll see this as we get out there. This is 42nd, and then this is Jason. All the amenity space for the building, the leasing operations, co-working, the retail bay at the corner of the building, and then live work units along the street on the north side. And then at the upper levels, this is the typical floor plate. It's pretty much all 2 bedrooms, 1 bedrooms, and some studios. We do have 3 bedrooms. There's one on the 2nd floor, and then the ground level, all those units are 3 bedrooms as well. And the building configuration is that kind of S shape. And so this is where we step back from the corner. That's where we get some interesting things you'll see in the podium out there as well, related to getting a pool hovering above a unit with a spa. And then in the rear courtyard, we incorporated a skylight to separate the patios, but then that also allowed Catamount to put their construction crane up through the building and allow for kind of ease of finishing out the construction on the project. And then these are the final renderings of what we hope the building will look like here in about a year. This is standing on the corner looking at that amenity deck. You'll see we've got some exterior lighting that will be incorporated on the building. Looking at that pool deck here, you can see kind of that configuration of what that ultimately will look like. The units up here, we have a continuous balcony along those faces there. And I don't know if we should be able to see some of the form work on the underside of that, where we incorporated a drip edge to make sure that that water's not running back to the building, and create a place to stop the traffic coating to ultimately protect the rebar and stuff in these slabs. Then one last image. This is the cidery. You have a double height retail space on the end. A little fun tidbit with the fire code, you can only have so much open area, and so we had to work with the design to limit how much opening we had to the south of the building. So with that, I will pass it over to Lauren.
All right, can you hear me? I'm Lauren. I'm with IMEG. I'm the structural engineer on the project. And for those of you familiar, this is the RAM model for our project if you use RAM structural systems software. One of the things that we did with this building was actually fully model the structure to be able to get the design loads at the podium level, at this level. And here's the pool Eric was talking about. There's some amenity space indoors here. There's the double height entry lobby and retail that Eric was talking about. And then hard to tell from this, but this is the end where those ground level units are, and the site is sloping as you go from Jason back to the alley. So just the systems in the building, we are using, because of that building height and the short floor to floor, we're using a MSR deck and what's commonly known as an Epicor system or an Infinity system. If you've heard of Infinity, they provide metal, load-bearing metal studs, walls that are panelized. So we were able to keep the structural depth at the upper levels to 5.5 inches, between 5.5 and 7 inches in almost every location. So our total structure depth was this deep throughout the upper levels. That really allowed them to give space to get the other items that they needed into the units and to get that acoustical component. Below that, we had a podium slab, and that's mildly reinforced, and a level 1 slab at the street level that's mildly reinforced. Part of the reason for the mild slab rather than post-tensioned was some of the street sloping and the stepping in and out of the building at that ground level. So we needed to have the flexibility at the first level to make any steps occur, add anything for ramps and pavement and things like that. And I'll highlight that in our plan a little bit later. We were able to use post-tension slabs at the garage, which turned out to be a 7-inch structure depth as well. Again, that helped us to kind of keep that bottom level up. We didn't, we're at this deep of a structure depth throughout the garage levels. We used shotcrete at the perimeter walls at the foundation. We ended up with a drilled pier foundation, which is pretty common in this area. There was a lot of discussion about whether or not we could use a mat slab sitting directly on that bedrock. But if you remember Eric's slide, the bedrock comes along, and as you go to the south, it suddenly dives off. And the problem with that is the mat slab wouldn't have any support on the south end, so you would tend to get differential deflection at that side of the building. So we opted instead, under the direction of the soils engineer, to use a drilled pier foundation. And the last item, which was a little bit late in the game, was using a system called ReadyCore. If you've heard of that, it is a form system for your cores where they build it out of out of metal deck. The whole entire system, they come, drop it on the site, rebar and all. It includes the stairs on the stair tower. And then they pour one level, and then they build the next level. They bring out the next level. So it's a little bit like a building block for your cores. And we'll be able to see that exposed metal deck formwork when we go onto the site. Here's some pictures of the structural system. One of the benefits of the Infinity style system is that Infinity panelizes everything. So most of the construction of the structure, once you get up above the podium level, is all panelized. They just drop it into place, attach it, go to the next one. Drop it into place, attach it. So that helps your construction schedule as well. Here's a picture of, this is at one of the stair cores. You can see the metal deck coming in, attaching to the ReadyCore system. And then a little bit of structural steel in this particular location to get that bearing line right at that core line. Here's a view of the front edge that Eric was talking about, right next to the, I'm sorry, that's at the back by the tower crane, overlooking where that big skylight would be that Eric mentioned. And then this is, oh, wrong button. And then this is what the metal deck looks like. You'll notice that it's a very tall profile. It's about a 2-inch profile. And at every bearing line, they crimp it down. What that does is help the concrete provide an interlock right at that location so that your metal deck at the bearing line doesn't try to separate from the concrete. And then one final structural piece is you have something called slab beams in this type of a system. And again, that's a 5.5 to 7-inch beam that acts as a bearing line where you don't have bearing walls in the units or where you have some kind of a transfer happening. So this is our typical upper level floor plan. You can see that the structural lines are very simple. This is the demising walls. We're able to clear span across the unit. I think the widest unit was probably around 21 feet, and we're still able to do that with that 5.5-inch profile. As you come around the building, these are the slab beams that I was talking about. So we have metal deck spanning in this direction, and we had a structural steel column here that goes to an Infinity panel here, and a slab beam in the middle of that unit. I think it happens that there's a kitchen or a living room right at that location, so we didn't have a bearing line. And then we're going to talk about this more, but right at the north end of the building, you can see that almost all the structure is actually that slab beam and column system. And part of that has to do with at the ground level where they have those stoops and they wanted to create a little bit of space along the sidewalk. They actually moved the exterior wall of the building in by about 2.5 feet, which meant that all of our load-bearing walls above would have been outside of the structure on the ground level. So we ended up going with this type of a system with the slab beams instead of the load-bearing walls. Here are some of the typical details from this Infinity style system. Main one, continuous slab on metal deck at a bearing wall. You can see that they actually stop and start the deck at each bearing wall line. Part of the reason for that is that the deck itself is actually quite heavy and difficult to deal with. So if you're trying to do 2 or 3 span continuous with that long of a deck, it would just be really difficult to place in the field. Here's a typical exterior condition. We do have some reinforcing in this system at the top, at the supports, to help get the continuous action that we want to have, to help limit deflection in the units. And here's a condition where we're turning This is load bearing on this side and it's parallel on this side. You can see that deck profile that comes in and creates a mechanical interlock between the deck and the concrete slab, which again helps to keep that slab from separating from the metal deck. There were a few select locations where we had structural steel headers at the exterior wall, where we had a very wide window bay. And this was challenging only because of the fire ratings that Eric was discussing, where we were at the exterior wall of the building on the east side. We're very close to the property line. And so trying to get that primary structural fireproofing around a steel header turned out to be pretty challenging. And I think we're actually still working through that detail under construction. And then finally, the Infinity system does allow for cantilevered balconies. In our case, we decided to stop the metal deck at the exterior wall and go with a cast-in-place slab outside. The main reason for this is I'm sure you've all seen apartment buildings where you're walking up and you see those decks and everything's rusting out. We didn't want to have that look in 5, 10, 15 years down the road. So we went with a purely cast-in-place and reinforced slab at the balconies. So I told you we were going to talk about that north end. Our structural line was all the way back here, and then about 2.5 feet out was where the bearing walls would have been. On top of that, our units at level 1, at the ground level, and at level 2 versus the levels above did not align with basically any wall throughout. So our idea of using structural bearing walls was just thrown out the window. We ended up with structural steel columns that we designed and these slab beams. These beams ended up being about 7 inches deep, which is still pretty good structure depth, but there were some challenges as far as locating the columns and getting that fireproofing fit in the assemblies. Here are some of the details. The slab beams look like this, where you have a short span. You could actually match the slab on metal deck profile, so you have a flat soffit. At some of the longer spans, you end up with a little bit deeper section, and so that would be like this beam here, where we had a total structure depth in this case of 7 inches. And then in our case, we also had this kind of torsional case at the edges, where we still have a bearing wall, we have the facade, we have all the weight of that right out at the outside face of the beam. And so we ended up with a little bit unusual detail for this case with ties. And if you can imagine trying to fabricate ties within a 7-inch beam, it was a little bit challenging. And finally, there's a special detail for the columns. You want to make sure that you're not causing crushing at the bearing points. Because if you remember, we've got 8 levels of framing coming down onto that single bearing point. So we have this unique column detail. They'll place the column with a cap and some headed anchor studs to grab onto the beam. And then there's a little stub column that's placed to get the top of the steel up to the top of the concrete so that we could avoid the problem of concrete crushing. And then the next piece of steel that comes out is field welded to the embed and placed up above. Going down to the lower levels, like I said, we had 7-inch PT garage slabs. You can see here it's a little bit of a view of down the middle of the garage, and you can access this side from somewhere. You can access this side from somewhere else. It's a little confusing. We'll see that on the tour, trying to walk around out there. At the main level, we ended up with a 12-inch slab, again, using mild reinforcing instead of PT because of some of the steps and difficult geometry that we had. And then any of you who have ever done a podium job might think that this 18-inch podium is pretty excessive. Oftentimes wood jobs with a podium, you end up maybe around 12 or 14 inches of the slab. You have to remember that the structure weight with a slab on metal deck for 8 levels is quite a lot heavier than a wood building. So our podium slab ended up quite a lot thicker than you would have expected. And finally, we ended up using CMU crash walls around in the garage spaces. Like I mentioned, the dead load is very high. We had quite a lot of uses on the main level. The other piece of this is not only does the street slope at the north side, it slopes at the east and the west sides as well. So there are some interesting spaces along the alley side. And we're actually placing the transformer and the equipment related to it on an elevated slab in the garage, which has its own set of challenges to it. Here's the main level slab. Just a few things to point out. You come in here into the garage from the alley. This white section is PT slab, and you slide down. You actually come down around. Then at the alley space, we have each one of these rooms at a different elevation based on the slope of the alley. It's represented by the arrow at the top. And then we also have the slope on the north side, and each one of these locations is a stoop set in from the foundation wall with a different elevation as you go along the building. So we'll see that we have some structural kind of wells taken out of the north end of that site. And then along the front, this is exterior space and this is exterior space. So again, there was a lot of structural stepping at the main level. One of my biggest lesson learned on this project is this is at the transformer room. All of the red that you see here is conduit encased in concrete. And that's because our transformer sits right about here. We've got primary lines coming into the building that have to go to all the equipment. We've got secondary lines that have to go to the other equipment. And it just turned out to be quite a lot of complicated concrete work. In hindsight, what I would have done is create a lower slab, fill it with dirt. They can put the conduit wherever they want to. They can bust some holes in my structure up here, and I think it would have been easier for everybody. But we're going to take a look at that when we go on the site. You can see this kind of maze of red concrete up above the P1 parking area. I think that's it for me, and I'll give it to Rodrigo.
Hello. So my name is Rodrigo. I'm with the general contractor, Catamount Constructors. So a little bit about the general contractor's role throughout this process is we like to get involved before construction starts. We like to think that we're a pretty good resource for the owners, the architects, and the engineers, just to kind of loop us in once the design starts getting finalized, just kind of letting us look at it, see if any huge red flags come up. So, we like to be a part of that before we start digging. And then just going down to construction schedule, our biggest thing is just to get the building done and ready as fast as possible. We know we have our clients want to get people moved in as quickly as possible. So bringing me to the first part, Infinity System, which is my team has never done it before. So it's a learning process, but it is an extremely efficient system, which as the general contractor, we always love anything that can save time, anything that can roll kind of quickly through it. And you can see here that these are all the panels that come in one truck, and they can unload these in one day and set them here just with a bracing, so they can just set one down, brace it up, move on to the next one. Later they'll go in, make sure everything's level and plumb before they set it. But the fact that they can get all these walls up in a day is pretty impressive. And as a system working with it for the first time, I would say that we'd like to work with it again in comparison to wood frame. One thing to notice is these chases are the MEP chases. Once this hits site, it's kind of putting the pieces together, but there is a lot of coordination that goes into this. I think before we even started digging, we had, I think, over 100 RFIs from Infinity alone, and Lauren and the IMEG team, was really helpful with answering those questions so they can manufacture all these panels, correctly. So we're avoiding having to do any field modifications. Once we get it all coordinated, it comes out, everything in hindsight should work. So that's really helpful when it comes out. And then here you have the shoring and then the deck on top. And as far as constructability, talking to our concrete guys, there's minimal rebar on the actual deck itself. All of this is just mesh, welded wire fabric. And then the only place we actually have rebar is the concrete beams, the slab beams themselves. So in general, a lot quicker of a process, a 5-inch slab compared to the 18-inch podium deck is just it's a lot easier to finish too. These Infinity systems have a very strict tolerance. So finishing on a flat 5-inch deck being easier than an 18-inch deck. And then one of the things we kind of working through the kinks, this being our first time, this is where we're currently at right now. We just poured the 5th level, and we thought we'd be able to get in on the 2nd level and start doing some of the light gauge framing and the layout, stocking material, but you need to have 2 floors of reshore underneath it. So once level 5 poured and hit strained, we were then able to go on the 2nd floor and remove all the reshoring. We just didn't think it would be that much, but it's kind of hard to work around. So that's just one kind of lesson learned there. And then moving on to the Ready Core, again, extremely efficient system. As the contractor, we love being able to work up and have the cores as we go up with the floors as well. It's just really helpful. And it's kind of the same thing where these roll up in trucks and crane them right out, put them together. Doesn't take more than 30 minutes just to kind of set it in place. And then, we're kind of fortunate to have a site where we can have road closures, but if you have a job downtown, limited space, it's an extremely efficient system that the truck can roll up, you empty it off, and then you're on your way. And then just kind of looking inside, as Lauren had mentioned, it already comes with the rebar, the horizontal, and we just install the vertical. And right here, kind of spaced throughout the cores, running along here, it just kind of sets in place. You screw it on. That's a female threaded rod right there. Set it in place, and then you can pour it. And pretty much one of the greatest things I think we've come to realize with these cores is that these stairs already come in them, and that is a huge plus in our industry. In stick frame and wood frame, you have all these ladders everywhere, and the fact that we have 2 stair cores on this project, so having 2 stairs as emergency egress is way more beneficial than having those ladders there. And having this platform here already makes it a lot easier to pour the stair cores, but the elevator kind of became a challenge for us because you just have an open shaft. So trying to figure out how to pour, when you're on the 8th floor when it's just an open shaft, we had to come up with a solution. Jesus. Create a platform that kind of we move up as we go. And it became easy once we figured it out, but that's one thing that, not having worked through it before, we just kind of had to come up with a solution for it. And here, we're working on whatever floor this is. We're able to stack those up as we go. So whenever we do pour that floor, we already have it set. We already have the stairs there, so extremely efficient. And then the only thing, this is kind of particular to our project. Our owners wanted some of the sections are exposed. And we quickly realized that once you pour and vibrate, some of the concrete leaks through the rivets. So kind of freaked out there for a second, didn't want concrete on the exposed deck. But that's just one thing to keep in mind if you're designing these with the Ready Core. If you do want to keep it exposed, that's just one of the things we had to work through. And then something we're getting into now as we do rough-ins is the MEP coordination within the parking garage itself. I feel like you run into this a lot with just height restrictions and needing to have fall on certain plumbing and fire sprinkler. We only have the plumbing right now, and then as soon as fire sprinkler goes in, I'm sure there's going to be some coordination that'll have to happen there. Fire sprinkler being a little more stringent. It's just always a challenge with the code requirements that you need for the height. But as Lauren pointed out, having the PT slabs in the garage levels helped us give us a little more room, which is always nice. And then here is the underneath the transformer, all that red concrete. We can take a look at it when we're there, but I would say that's definitely one of our biggest lessons learned on this project. Making sure that's coordinated before you get out there. We thought we had enough time to kind of figure it out beforehand, but it started getting to the critical point. So always make sure you know with Excel with what they need and all their requirements. And then once we go out on site, we'll be able to walk with you guys. And any questions you have while you're out there, be more than welcome to answer them. It's an Excel requirement, so yeah, people don't drill.
For those of us who are tuning in on the webinar, can you repeat that question?
What for the red concrete?
Was there a code requirement for the red concrete? Okay. Rodrigo, Lauren, and Eric, thank you so much for your time and sharing your experience with us. Can we give them a round of applause, please? Thank you. So if you're on the webinar, okay, we do have a question from someone on the webinar. Lauren, can you mention the pool structure and if there were any challenges during construction? Yes.
Yeah, so the pool is within the podium slab. What we did was basically create a concrete vault of big concrete beams so that they could place a pool, basically like you would place a pool in an underground. They just spray a bunch of gunite and make it the shape that they want. So we'll see it when we go on site, but there's a big trough in the podium slab. And I think the challenge wasn't for me. It was a little bit more for Eric to try to see what the heck we could fit underneath that big trough at level 1.
Are there any questions from those present? Yes, one more. I don't want to carry this in front of the microphone. Okay. Were they rental units or were they condominiums?
Rental. So 10% are affordable, not tax credit funded. And then the rest of them are just market rate. Good question. How do you define affordable? So one of the ways that can get defined is if it's funded through the low income tax credit process. In Colorado and a lot of states, there's that low income tax credit process that then funds specific projects. And a lot of times you say those are affordable projects. They tend to be anywhere between like 40 to 60% of the area median income. These affordable or attainable housing units, I'm not quite sure what that rate is. We weren't terribly involved in that kind of back-end financing discussion of how Prime West was able to fund those types of units. And so it really can depend on the specific market, but affordable tends to be related to that tax credit process. And then attainable is more like 80% of the area median income to maybe 120%. And those tend to be more outside of that tax credit process. How much of the Infinity system and Ready Core were delegated design?
Yeah, so we designed the slab on metal deck and the reinforcing, and we provided loads at the load-bearing walls, and Infinity did the design for that, including any openings or headers that were required. The question was, did we have to sedate Eric to get him to agree to a balcony with no thermal break? The real answer is that it was dictated by the system. There wasn't enough depth to provide some kind of other kind of typical thermal break product. Like you may have seen steel connections that have a gap at the exterior wall. There just wasn't structural depth to support that kind of a system, and it was going to eat into the head height. So in order to keep that structural depth really minimal, it wasn't actually much of a fight, I got to say.
We compensated through other means in the energy modeling for the building. And so to offset those conditions, you'll see there's not a ton of balconies on the project. The primary location is right above the pool deck. But so that was one way that we managed that, but then also just efficient mechanical systems and energy performance in other locations of the building.
So the question was were the holes in the deck pre-coordinated? And are you talking about in the MSR deck or in the cast in place? So we pre-coordinated any penetrations through the lower levels up through the podium. And then at the upper levels, it's going to be core drilled because there's almost no reinforcing or anything of concern at the upper levels. Anybody else?
Okay, one more round of applause for our presenters. Thank you guys so much. Okay, so we're going to transition to the tour. Rodrigo, feel free to chime in if you have any logistical things you want to add, but we're going to proceed with the tour, the hard hat tour, in two groups of no more than 20. And they're going to go sequentially, one after another. So if you have somewhere to be later tonight and you want to be one of the first to be done with this hard hat tour, I would make haste to the project site. And you are welcome to walk or drive. This is a map, and I think we've also distributed some maps to y'all. It's about a half-mile walk, fairly easy to get there. 3 blocks east and then 3 blocks north. Look for the cidery. As soon as you pass the cidery, it's called Waldshanky. Meet on the corner of 42nd and Jason. Bring your PPE. I think we have a small number of extras if you need them. Extras on site as well. One more thing, is Josh Youngquist here? He had to leave. Okay, so we had Josh. We have Dave, who is representing ReadyCore, I guess, at this point. Yeah. So if you have any questions specific to ReadyCore, obviously you can ask Lauren, but also Dave. He'll be joining us on the tour, I assume. Okay, fantastic. Yes. Excellent. So Rodrigo, I guess as soon as we get 20 people on site, we'll begin the first tour, and then the next, are we saying about 30 minutes per tour, 45 minutes per tour, roughly? Okay, fantastic. Any more questions about the logistics going forward? Yes.
Yeah, I did forget that. One of the things that we did with the core design is we designed the main reinforcing with some input from ReadyCore because their system really only works with specific spacing. So, for example, I think we had number 7s at 8 inches and they came back and said no. So we adjusted the size and the spacing of the reinforcing. But then ReadyCore did the design of the attachment between the slab and the cores, also between any beams, slab beams in the core, and then between the couple of steel beams that came on. They had to do design of that because their system has very specific limits on where you can and can't attach to the form itself. Did I miss anything? I believe that we ended up at 10 inches total thickness, which is a structural thickness of 8 inches between the pieces of deck.
That's all I have. See you on site.